So we have our server, we have our SSH key, we are now connected to our server. What we're gonna do next is we're gonna buy a domain. So if you have a domain, and I know most of you probably are squatting on a few, that's okay. If you haven't, I'm gonna walk through how to buy one, and I'll even say who to buy it from, but that's more my opinion. And then we're gonna put it all together. We're gonna connect your domain to your server, and then now we're cooking. So now I'm going to roll up my sleeves because now is where we get really, really serious. Before, some of the stuff you may have done before, creating SSH key, maybe even creating a server, but we're gonna hook it all together, and by the end, we're gonna understand how the internet works. How does any of this work? So how does the internet work? Probably my favorite interview question. I don't ask it anymore because I'm kind of known for it, so you're not getting any free passes if I ever give you an interview. But I like it because the internet is a complex piece of machinery. I said it before, but I'll say it again. The internet is one of mankind's greatest achievements. And what's great about it is it wasn't any one person's vision. Yes, it was sort of quasi-invented by DARPA, which is the military, the US government created a loose sort of internet, but nothing on this scale. They just wanted computers to be able to talk to each other in some loose way. Some universities wanted to talk to each other. But the internet itself, where we are today, is not the result of any one company or person or organization. It is a collection of people, a collection of organizations, a collection of technologies that somehow makes it so that I'm talking to you live in a completely different part of the world, and you're all tuning in, and we're all creating these things. And that's really cool. I don't know. I think we get so caught up in the day-to-day programming and arguing over frameworks and it's VI or Vim or Emacs or just the arbitrary things we get caught up in our day-to-day, and forgetting the magic of how all this stuff works together, and it's incredibly complex. So I want to talk a little bit more about that. So normally when I say how does the internet work, people assume it's some magic. The browser talks to a server somewhere. How does the server talk back to you? Some other magic? I don't know. And that's usually the answer I get. The reason why I like to ask how does the internet work is because it gives you a chance to shine on any part of the stack that you want. Remember earlier we talked about what a stack means? I mean the operating system, the web server, the application server. It doesn't matter. You can dive into any particular part, and you can give me a good answer. That's why it's a really free-form answer. It tells me how thoughtful you are, how much kind of research you've done, and kind of how curious you are. Because most of this stuff you don't need in your day-to-day if you're just creating web pages. You're not going to need to know how to spin up a server and open a firewall and things like that. That's probably done by someone else. But it shows me how curious you are and how much you kind of pick up on the overall ecosystem that we exist in as front-end engineers. The core of the internet is built on cooperation and rules. Some cooperation is monetized, so internet service providers, well, they get paid. We pay them to access the internet, and they are paid to maintain their part of the internet, the fiber lines, et cetera. But what about the other parts? What about, I don't know, talking to a server? How is it that I can SSH into a server? Who made Ubuntu say you need to implement SSH, and then OS X implement SSH, and then made it so they can talk to each other? Well, it's just cooperation. It's just saying hey, here's a common standard. We all agree on it. Let's implement it in this way, and now we can all use it together. And that's what the internet is, just these series of decisions of all of us, how we came together. And I'm going on and on about it, but again, it's so magical, how this all mysteriously works. By the time we get to the end of this, you'll be like, how in the world do all these disparate pieces of technology come together and make it work, even though they're completely unrelated to each other? So this is a very, very simplified diagram of how a request works. You have your computer. Your computer has a network card of some sort, an interface outward. In the old days, you had to buy a modem. You had to buy an exterior modem. I don't know if any of you are familiar with phone lines. I'm dating myself, but there's something called a 56K modem that ran over your phone lines. You had to plug it in, and you couldn't use the phone at the same time as you're on Napster or something trying to download an MP3. Now I'm dating myself for sure. But all computers need a network card. Without that, they can't talk to the internet. Pretty simple. It's built in now. It didn't always used to be. Your network card is going to talk to a router somewhere. Okay, maybe if you work on an ISP, you can plug directly into one of the servers there. But if you do that, I don't know why you're taking this course. You probably know a lot more about networking than I do. But every network you connect to is connected to a router. The router enables so we can have one IP address So we're here in Minneapolis right now. We might have one IP address that connects to the internet, yet all of our computers have different internal IP addresses. And that's what the router gives us. It kind of fans out and allows us to multiply our connections without making too many more. So your router will connect to probably a modem, maybe not, but probably a modem. I didn't even include that here. That connects to your ISP, the person you're paying to provide internet access to. Everybody has an ISP of some sort. That ISP may be a tier 1, it may not be a tier 1, but that ISP eventually is going to connect to a tier 1 ISP. Those ISPs are known as the backbone. The backbones of the internet are the big players. They keep everything running. If the backbone goes down, you feel it. And we've seen it a few times in probably the past year. Usually every year, some part of the internet goes down. And it's usually one of these backbones that go down due to some misconfiguration or something like that. From there, the backbones usually talk to another backbone. And these backbones are really, really fast. These tier 1 ISPs, they process speed at probably 100 gigs a second or something like that. And that's pretty slow these days. But that's like the minimum you need to become a tier 1. Those ISPs will likely connect to a data center somewhere in the world. Whether we talk about Rackspace or AWS or DigitalOcean, they're connecting to a data center. That data center is going to have a server cluster. That server cluster is owned by you or me or any corporation or company. From the server cluster, you usually hit a load balancer of some kind. So you don't just connect to one server. That wouldn't make a lot of sense. You'll overload that server if we're all hitting the same one. So we have a load balancer to balance that out. And that ultimately connects to your server. And if I say how the internet works and you have this slide or you have this in your mind, you're doing pretty well. I left out a lot. There is a lot here not shown. We didn't talk about BGP. We talked about modems a little bit. We didn't talk about interconnection agreements and like how does a ISP in the US connect to an ISP in England? And how do they talk to each other? Where do those cables run? Again, it's amazing this all works. Like look at all these different steps to pull up a web page. And we didn't even talk about the software you need. Like we didn't talk about browsers, the standards they run on that can read TCP requests and HTTP requests and translate those into something that is renderable. There's a whole ecosystem. So think back to that iceberg picture from the beginning of class where you see front end and you see everything else. This is part of the everything else that makes everything around us work. So some terminology. The internet is a network of networks. That's all it is, nothing fancy. In the beginning days, it was just some university nerds talking to each other on their very slow mainframes. Now, we're all part of the internet. An intranet is a private network. If you work at a big corporation, they have an intranet. Most people do these days. That's just a private internet. That's not connected. It is connected to the outside world, but it doesn't let people in. And we do that via firewalls, VPNs, et cetera. LAN is something you don't hear as much. Anybody remember LAN parties? Yeah. See, I can tell how old you are based on if you're nodding along or not. It'll tell me very clear because in the old days, before the internet, or when the internet was too slow to actually do that much, you had to be on the same network and play the same games in the same room generally or in the same building. Yes, LAN is great because, like Mark was saying, there's no latency, generally speaking. And then there's something called a WAN, a wide area network. Not something as used as much, but it's similar to a LAN. It's just, say, multiple buildings this time. But that's generally been replaced by intranets. And I keep saying IP address, et cetera. IP just stands for Internet Protocol. Remember, the internet's built on rules and cooperation. So those rules are generally in the form of standards and protocols. Internet Protocol just specifies, hey, what is an address connecting to a computer? What does that look like? What are the rules around it? Are there letters allowed in there? Is there spaces? And Internet Protocol just says, like, no, here's what an IP address is. Here's the number of blocks we have. And I'll talk about that in 1 second when we get to IP addresses. And here's the rules that govern how this protocol works. An IP address is just a label assigned to any internet-connected device. Every single device on the world has an IP address of some sort. Now, a lot of times, because they're behind a router, that internet address is just 192.168.something. Those are considered local addresses. But again, when you connect to the wider internet, you're going to have generally one IP address. And that's the beauty of the router. It allows this kind of multiplexing. So I don't think people know this, but like companies own blocks of the internet in different forms. They own blocks of IP addresses. So I forget off the top of my head which governing body owns IP addresses, but somebody does. And somebody says, hey, what's a good example? Cloudflare. Cloudflare owns, it's like 1.1.1, and they own like an entire block. Google owns an entire block of addresses. Amazon owns this entire block of addresses. The government owns probably the biggest block of IP addresses. And again, you have to buy these things from other people. So it's kind of a weird dichotomy here where the internet's open and free, but it's also not. It's also owned by people too. But it generally kind of all works out, this private-public cooperation. So way back in the day, and this is more of a math thing, people said, hey, let's create an IP address. An IP address will have 4 places, 4 different blocks to specify the location of that IP address. So when we take IPv4, so it's going to be like something like that 127.0.0.1, et cetera. People are like, that's enough. That gives us roughly 4.3 billion addresses. That should be plenty, right? In 1990, when they're coming up with all these standards in the 90s and the 80s, that seemed like a lot. They're like, we'll never have 4 billion connected devices to the internet. It turns out we ran out of IP addresses like quite a while ago. This was a problem. 4.3 billion is not enough. Hence, we created IPv6. IPv6 has 340 decillion, if I'm pronouncing that right, addresses. So that effectively means we will never run out of IP addresses. I say this now, and they probably said the same thing 30 years ago. Like, we're never going to run out of IP addresses. But I think we're pretty safe with IPv6. IPv4 is 32 bits. IPv6 is 128 bits. So that is exponentially larger. So we're not really going to dive into IPv6 too much. But if you ever see it, it is a legitimate address. It's just one of the more modern standards.